Welcome to Module 7, Demand Estimation and Forecasting. Our learning objectives are the following: to predict sales and prices using time series regression analysis and use dummy variables to account for cyclical or seasonal variation in sales. Discuss and explain various significant problems that result when using statistical methods to calculate demand. To distinguish the nature of the phenomenon denoted by the series of observations and forecasting, that is, forecasting values of the time series variables of the following methods: simple moving averages, weighted moving averages, naive method, mean absolute deviation or MAD, mean squared error or MSE, and mean absolute percent error or MAPE. Demand estimation is a forecasting method zeroing in on future consumer buying behavior. It forecasts demand for commodities by applying a bunch of variables. Changes in buyers' pay levels will influence demand. Changing in price will influence also demand. Once equipped with this data, the administration can then start to settle an essential business decision. Regression analysis is statistical measure utilized to form connections between the variables, the dependent variables, and the different elements that will influence it, or the independent variable. It is given by the equation y is equal to a plus bx, where y is the dependent variable, x independent variable, b slope of the line, and a is the y-intercept. Regression lines are helpful in predicting processes. Its goals is to explain the relationship of the dependent variable and the one or several independent variables. Positive correlations have points that move upward to the right. As x values rise, y values rise as well. As x values decline, y values also decline. For example, when studying animals, the height usually rises as size increases. Negative correlation is an association between two variables in which as one variable rises, the other declines, and vice versa. A perfect negative correlation denotes that the association that is present between two variables is perfectly contrasting all of the time. A scatter diagram is applied to measure the association between the axes with one variable. In the diagram, if the variables are related, then the point declines along a curve or line. A scatter diagram or scatter plot provides knowledge of the nature of association. In a scatter correlation diagram, if all the points stretch in one line, then the relationship is perfect and is in harmony. However, if the scatter points are generally dispersed all over the line, then the relationship is said to be low. If the dispersed points lie near a line or in a line, then the relationship is considered as linear. Sample problem number 1. The data contained in the table show monthly expenses in 100,000s and sales in millions over a period of 6. Estimate the association between sales represented by y and promotion expenses represented by x by using least square regression line, and also forecast that if a firm spent 700,000 pesos on promotions, then what would be the sales of that firm? So for the solution, we are creating a table where x is representing the promotion expenses for periods 1, 2, 3, 4, 5, 6, and then its corresponding sales represented by y with 3, 15, 6, 20, 9, and 25. We further tabulate the periods and then solve for the x squared and the xy shown in column 3 and column 4. After which we are going to get the summation. The summation of x is now equal to 21, the summation of y is 78, and the summation of x raised to the power of 2 is 91, and the summation of the product of x and y is 326. Now, using the equation y is equal to a plus bx, where a and b, the formula are shown, we are able to get the value of a, which is equal to 2.39, and b, which is equal to 3.03. Thus, the estimated correlation or regression line between sales and promotion expenses is y is equal to 2.39 plus 3.03x. Sales is equal to 2.39 plus 3.03 times 7, giving us 23.6. Since sales is given in 100,000, therefore the value is 23,600,000. Sample problem number 2. Aces Construction Company renovates homes in Cebu City. Over time, the business has found that its peso volume renovation work is dependent in the Mandaue City area payroll. The data for the company revenue and the amount of money earned by wage earners in Mandaue City for the past 5 years are shown in the table. For the solution to problem number 2, we tabulate the Dumlaos sales in 100,000 represented by y as the following: 3.0, 2.0, 3.5, 2.0, and 3.0, with its corresponding payroll represented by X in 1 million pesos, with 2, 3, 2, 5, and 4 million respectively. If we are going to further tabulate the sales represented by Y and get the summation, we are able to get 15. And for the summation of the payroll, it's equal to 20. And the summation of x to the power of 2 is equal to 90. And the summation of x times y is 62.5. Applying the formula for A and B and substituting the different values, we are able to get A equal to 100 over 50. And this can be further reduced or simplified as 2. For the value of B, substituting the values, we are able to get B is equal to 0.25. The estimated regression equation thus, y is equal to 2 plus 0.25x is equal to y is equal to 2 plus 0.25 times payroll. If Aces Construction Company wishes to have a payroll of 5.5 million pesos next year, an estimated sales for Aces Construction Company in 100,000 is equal to 2 plus 0.25 times payroll. Substituting the values of 5.5 million, we are able to get a sales of 337,500 pesos. Forecasting is a method that involves historic information as inputs to make informed evaluations that are present in deciding the bearing of future patterns. Organizations use forecasting to decide how to distribute their financial resources or plan for expected costs for an impending economic period of time. Forecasting is a strategy that involves recorded information as inputs to make informed assessments that are present in deciding the course of future patterns. Organizations use forecasting to decide how to designate their spending plans or plan for expected costs for an impending period. This is ordinarily founded on the projected demand for the commodities sold. Anticipating results and issue or set of information. Business analysis make hypotheses in regards to circumstance being investigated that should set up before forecasting variables are measured. In view of the matters measured, a fitting set of information is chosen and used to control data. The information is examined and the forecast is recognized. At long last, a verification period happens where the forecast is contrasted with the real outcomes to build up more exact future forecasting model. Stock investigators utilize different forecasting techniques to decide how a stock's price will move later on. They may take a look at income and contrast it with economic markers. Changes to monetary or statistical information are seen to decide the connection between the multiple variables. These connections might be founded on the progression of time or the event of explicit occasions. For instance, a sales forecast might be founded on a particular period, the passage of a year, or the event of an occasion, the acquisition of a contender's business. Types of forecasting methods. Number one, weighted moving average or WMA. The weighted moving normal is a specialized indicator that merchants utilize to create exchange plan and buying choices. It relegates more noteworthy weighing to current data points and less weighing on past data points. The weighted moving average is determined by multiplying every perception in the data set by a foreordained factor. Merchants utilize the weighted average tool to create exchange signals. For example, when the price activity moves towards or is greater than the weighted moving average, the sign can demonstrate leave the transaction. In any case, assuming the value plunges close or just underneath the weighted moving average, it can show a favorable chance to enter a trade. Utilizing the weighted moving average to design pattern bearing is more precise than the simple moving average, appointing indistinguishable weights of all numbers in the dataset. For instance, follow the means when registering weighted moving normal. First, identify the number intended to average. The primary step is to produce a list of the user's numbers to determine the weighted average. The closing prices of IVY inventory can be utilized for the period commencing June 1 to June 5. The closing prices are 91 pesos, 90 pesos, 89 pesos, 89 pesos, 90 pesos, with the primary number being the present. Next, determine the weights of each number. Subsequent to recognizing the numbers for which to compute the weighted average, the following stage is to decide the weight of each number to determine how much every one of the numbers weighs. In such instant, at that point, designate the most highest weighing to the present data point out of an arbitrary 15 points as displayed in the table. Multiply each number by weighting factor. After calculating the weighting for each number, the next step is to multiply each of the numbers from June 1 to 5 by the corresponding weighting factor and then add up the resulting values. The data is presented in the table. The formula for the weighted moving average is displayed, where n is the time period. Next, add up the resulting values to obtain the weighted average. The last step is to sum up the resulting values to obtain the weighted average for the closing prices of AB. WMA is equal to 30 pesos plus 23.47 plus 17.80 plus 12 plus 6.07. Giving us a total of 89.34. Therefore, the weighting moving average for the period from June 1 to June 5 is 89.34 pesos. Simple moving average. A simple moving average, or SMA, is a sort of moving average that shows usual prices for a specific product for a particular time frame or look-back period. Moving averages are a sort of estimation usually utilized by stock market experts to study price changes by computing the averages at set intervals throughout days, weeks, months, or years. The reason for a simple moving average prediction is to assist with stock experts, entrepreneurs, and different professionals figure out which stock to purchase and when to do as such. More particularly, basic moving forecasting assists people decide if the price of a product can hope to see an upswing or price increase or slump, what we call price decline. Through doing this, people can settle on savvy speculation choices in light of products with upward patterns. These are the procedures in calculating simple moving average. Number one, ascertain the time frame intended to review. The primary step to compute the simple moving average of a product or service is to consider time span in which you necessitate to pull information from. For instance, you could decide the ideal time period to be 5 days, 50 days, 100 days, or 200 days. Number two, identify the highest price points for each interval. Assuming you choose to pull price data for 7 period, this implies that every day you audit stock prices for a product and choose the biggest price point, the time span, for example, 1 day. Since you need to decide the simple moving average for 7 days, you really want to inquire regarding the prices of the stock costs every day, noting the greatest price point for the 6 periods that remain. Here is a sample data that displays the price changes for an espresso brand stock. Period 1 to period 7, the prices are 8.95, 8.50, 8.85, 9, 8.70, 8.55, and 8.65 pesos. Number 3, get the total each price point together. Once you noted the greatest prices of the stocks for a specific product over a period of preferred span of time, you obtain the sum every price point to one another. As an example, 8.95, 8.5, 8.85, 9.0, 8.70, 8.55, 8.65, which is total to 61.20. Number 4, divide the sum by the number of determined time intervals. After summing each price point together and obtaining the answer, you divide the sum by the number of time intervals you noted. As an example, 61.20 pesos divided by 7 is equal to 8.74. Hence, 8 pesos and 74 cents is the average stock price for a brand espresso over the course of one period. Regression analysis. Since we know how the general connection between the two variables is determined, we can foster a regression equation to measure or foresee the variable we want. The following is the recipe formula for a simple linear regression. The y is the value where we are attempting to figure. The b, or the slope of the regression line. The x is the value of our independent value. And a addresses the y-intercept. The regression equation just depicts the connection between the independent variable y and the independent variable x. Our formula is given by y is equal to a plus bx, where a is the value of y when x is equal to 0, b slope of the line, y the predicted dependent variable, x predictor or independent variable. For example, Innate Corporation has a chain of 10 stores in Metro Manila. Sales records and profiles for the store outlets are provided in the table. You get a regression line for the data and forecast for an outlet presuming sales of 30 million pesos. So for the tabulation, we have sales represented by X in millions and the profit Y in millions. The third column is the product of X and Y, and the fourth is the square of X. As displayed in the table, by getting the summation of X, we are able to have 190, For the second column, the summation of y is 111.5. For the summation of xy is equal to 2,184. And the summation of x to the power of 2 is 3,694. So using our equation, y is equal to a plus bx, where a is the value of y when x is equal to 0, b slope of the line, y the predicted variable, x the predictor variable. We are looking for the value of x. We know that x over n is equal to the summation of x. Now working on the equation, we are able to get x is equal to 190 over 10. Therefore, getting the value of x equal to 19. Next step is we are going to look for the value of y. Y is equal to the summation of y over n. Substituting the values, 111.5 divided by 10 gives us the value of y to be 11.15. Next, we are going to look for the value of b. We are going to use the equation, the summation of xy minus n times xy divided by the summation of x squared minus nx squared. Substituting, we're able to get 2,184 minus 10 times 19 times 11.15 divided by 3,694 minus 10 times 19 raised to 2. Simplifying further, we are able to get b is equal to 0.78. Next, we are going to solve for the value of a using the formula y minus bx, coming from the original formula y is equal to a plus bx. Substituting the values, we have 11.15 minus 0.78 times 19. Simplifying, we are able to get a equal to negative 3.67. The estimated regression equation, as mentioned, is equal to y is equal to a plus bx. Substituting back the values, we get negative 3.67 plus 0.78 times 30. And simplifying it further, we are able to get 19.73 million. Naive forecast. Naive forecast is the least difficult method. It essentially involves the real demand for the past period as the predicted demand for the following time frame. This makes the hypothesis that the previous will recur. It likewise expects that any parts of the time series parts, patterns, seasonality, or cycles are either reflected in the past year's demand or do not occur. An illustration of the naive forecast is presented in the table. Observe the demand on period 1 was 35. The naive forecast for the upcoming period is 35. Mean absolute deviation, or MAD. It is a method for calculating the precision of a forecasting model by taking of the absolute value. Mean absolute deviation, which is also called MAD for short, is the average of the absolute value or the distinction between real figures and their average value, and is utilized for the computation of changeability in demand. Assuming the MAD is low, it implies that the model is exact. In the event that the MAD is high, it is less precise. MAD is given by the equation forecast errors divided by n. MAD is equal to forecast errors divided by n. Based on the displayed table, there are 8 periods and actual demands are also included. And the table shows errors where alpha is equal to 0.2 and another error where alpha is equal to 0.5. Based on the computation, alpha with a value of 0.2 is higher than MAD of alpha equal to 0.5. Thus, the alpha of 0.5 is preferred because its MAD is smaller. For the computation, we will have F equal to forecast plus forecast error percent times actual demand minus forecast. So for the three examples, at error equal to 0.2, we are able to compute F is equal to 20 plus 0.20 times 35, the actual demand, minus the forecast. Simplifying it, we are able to get F is equal to 23. This 23, which is a forecast value, can be seen at the third column of the table that was displayed. Further, we can compute for the value of F for 23 plus 0.20 times 46 actual demand minus the 23, which is the forecast value. Simplifying, we are able to get 27.60. Further, if we are going to consider 40 as the actual demand and the previous computation as the forecast, which is 27.6, we are able to get 30.08. This computation are included in the third column for forecast values at error or alpha, which is equal to 0.20. If we are now going to consider error at 0.5 and calculate using the same formula, but the values for the first computation is 35 for the actual demand minus 20. Simplifying it, we are able to get 27.5. And for the next forecast, using actual demand of 46 and the forecast of 27.60, we are able to get 36.75. The solution are displayed in the table. You can check columns 3, 4, 5, and 6 for these values of the computations. Mean squared error or MSE. MSE is a method for calculating the correctness of predicting model with the average of the squared error terms for a predicting method. MSE is computed using the formula, the square of the forecast errors divided by n. For our sample problem number 1, we are tasked to solve for MSE at alpha equal to 0.2 and alpha equal to 0.5. For the first solution, alpha is equal to 0.2. As displayed in the table, we have 6 periods that we have considered. The second column shows the demand, and the third column we are able to compute for the forecast error at alpha equal to 0.2. We also computed the squared forecast error, and these are the following values: 225, 529, 184.9, 96.81, 438.48, and 45.56. Ultimately, we are going to compute for the MSE, and our value is 303.30. For the second error at alpha equal to 0.5, the same formula we have used. And finally, if we are going to use the same formula, our MSE will be equal to 141.79. Based on the computation, the MSE of alpha, which is equal to 0.2, is greater than MSE of alpha, which is equal to 0.5. Thus, the alpha, which is 0.5, is chosen since its MSE is lesser. Mean absolute percent error or MAPE. MAPE is a method for measuring the precision of a forecasting approach by obtaining the average of the absolute errors as a percentage of the observed values. In the shown table, there are 5 periods, and we have the actual demand, the values for the forecasted demand, also the forecast error, the absolute error, the percentage error, absolute accuracy, and arithmetic accuracy. The formula that we are going to use are the following. Forecast error is equal to actual demand minus forecasted demand. Percentage error is equal to absolute error divided by actual demand times 100%. Absolute accuracy is 100% minus percentage error. Arithmetic accuracy is equal to actual demand divided by the forecasted demand times 100%. For the RAPE, our formula is equal to absolute error divided by the actual demand times 100%. Substituting the values coming from the table, we have 65 divided by 275 times 100%, having MAPE equal to 24%.